Hello students, and welcome back to another lovely day of physical science. In today's lesson, we are going to be learning the basics of graphing. So in this case, when you're creating a graph, what you want to do is you're going to have your y-axis and your x-axis. Your x-axis runs horizontally, that is, it runs left to right. Picture like a horizon, if you're overlooking the water. It's running left to right or flat. Your y-axis runs up and down. One way students remember y-axis is they think of the stem of the y as coming down and creating that up and down or vertical line. When you're doing this, what you need to make sure you do is if you're looking at your data, you need to look at your independent and dependent variable. So what those are is an independent variable is not changed by the other variable. A dependent variable is the one that changes because of the other variable. A lot of times your independent variable is what the researcher is controlling in an experiment, and dependent is what they're measuring. And we'll explain more of this coming up in this unit and in future units. Another thing you need to make sure you do is label what the variable is on both the y and the x-axis. So let's take a look at what these would look like. If you've done this before, you can pause the video and try and label a graph for a runner's time in seconds and their distance in meters using the format of y versus x. Otherwise, we can go through and solve this together. So what I would look at is I see runner's time and I see distance. I need to ask myself, well, which of those is independent of the other one? We really can't control time. So time typically is going to be our independent variable, and then the distance that they run depends on how long they've been running for. So that's your dependent variable. So our independent variable, our dependent variable is going to be the distance that they ran. Our independent variable is going to be their time, and we need to label units of seconds. Just like over here, we can't just say distance, we need to say distance in meters. If we just say distance, it could be miles, it could be yards. We don't know. Same thing with time. Time, we have to put units of seconds because that's what we measured it in. I can't just put time because otherwise, is it time in minutes or hours or days or months or years? Like, it's important. And then, when you title your graph, the simplest way to do that is to just create a title that is y versus x. So in this case, just your distance versus time. And there you go. You created a title, you labeled it with units, and everything is good. So with that, the importance of independent versus dependent variable, you could never have distance on the bottom and then time on the side because distance doesn't control time. We can't control time. Time is pretty much always going to be an independent variable. Then what you need to do is decide on what intervals you will be using on the axis. So notice here, this graph starts at 66 and 1991. That's okay, you can do that. We would not want to start a graph down at 0, 0 for this data because we would have 1990 years with just no data there. So you can put your graph and create it to fit all of your data. And then again, you'll see that your independent variable is time, and then his weight depended on what year it was. Alright, what I would like you to do is please pause the video and just practice plotting these 6 points. Alright, now that you've had a chance to try plotting those points, and hopefully you've learned that in previous courses, if not, we'll run through how to do this really quick. So when you are looking at a graph, again, you have your x variable and your y. Well, x again is horizontal, y is going to run vertically. And when you look at points, the first point listed is always x, so that's how you move left and right. And your second point is always going to be y. That is how it moves up and down. So looking at the graph here, the center is typically going to be the point 0, 0. And that would make this, just for the simple graph, point 1, 2, 3, 4, and 5. So going to the right is positive, and going up is positive. So 1, 2, 3, 4, 5. Then, going left is negative, so negative 1, negative 2, negative 3, negative 4, negative 5. And going down is going to be negative. So now if I want to start plotting these points, like the point 3, 2, we would need to count our way over 1, 2, 3, because we have to move our x point first, and then going up 2. And so our first point would come right here, and that's point 3, 2. Then we would have the point 5, 3, where we go over 5 and up 3. And then the point 3, negative 2. So we have to go to the right 3 spots again, but now we're negative 2, so we're going to go down 2 spots. Then we have negative 4, and notice that's for our x variable, so we have to go left 4 spots, and then up 1. Then we have the point 0, 1, so we're actually going to stay right on this line. We're not going to move left or right, and then we're just going to go down 1 spot. And then our last one is negative 3, negative 5, and there's that final point. So when you plot the data points that you collect on the graph, we call that a scatter plot, so that's what you see right here. And if there's a relationship that appears linear, that is, it almost appears like it's kind of fitting around a straight line, then you draw that line, and that's what we call our line of best fit, or our trend line. So if you went through and you plotted this data, you could draw a line of best fit for this following scatter plot. And again, it needs to be a perfectly straight line. You're not going to sit here and connect the dots or anything. You just draw a perfectly straight line. So if I draw this line, that's great. That's my line of best fit. But again, your line might be different than mine. You might have a line that looks like this. You might have a line that looks like this. Neither answer is better or worse. It's an estimate of what the average of those points is. So you can be off by a little bit, but really you usually want to try and have the same amount of dots on top of the line or above the line as you do below the line. Just something to try and average that out. Then when you look at that, the slope is positive. That is, you know that this is going to be a positive number slope because it's moving up and to the right. Then you're going to have what we call our y-intercept. And that is where it intercepts this y-axis. So for each line, it has a different y-intercept. So for your green line, and again, you'll get practice on this in the upcoming notes, your y-intercept would have a value of about 2. If you drew the red line, you'd have a y-intercept of about 1.3, and then for your blue line, you'd have a y-intercept of about 0.5. So they're all going to have a different y-intercept because you're creating a different line of best fit. You could also have data that looks something like this. And again, you might get different data. If this is my line of best fit, you might have one that looks like this. You could have one that looks like this green line. Doesn't matter. It's as long as it's a pretty close estimate. Would have a negative slope because the line is running down and to the right. So this is what negative slope is going to look like. And that's important to pay attention to when you're solving for this variable m in upcoming slides, is to know that this is what the line would look like if you get a negative m value. And then again, you're going to have your 3 y-intercepts. And in this case, the green line would have an intercept of about 8.75. Red one might be about 8.5. And then the blue one would be right around 8. Now what I would like you to do is please pause the video and try and solve for what you think the number of total miles that this car traveled is. So try and actually interpret data from this graph. Alright, now that you have had a chance to try this, let's go through and solve for it. So what we're looking at is how many total miles did the car travel? Well, in this case, we have the point 0, down here, and point B is actually at the 60-mile mark. So therefore, from point A to B, alright, what I would like you to do now is try and solve for this question, and that is, how many total miles did the car travel? So actually look at the graph, interpret the data, and decide how many total miles did this car go. So please pause the video and try this on your own. Okay, now that you have had a chance to try this one on your own, I will tell you that the answer is 290 miles. And let's take a look at why. So in this question, we're going to figure out how many miles did this car go. So it started at this point 0, 0, so it hadn't traveled any distance yet, and then it's worked its way over to point B, which is at a distance of 60 miles. So therefore the car has traveled 60 miles. Then from point B to point C, it doesn't change at all. It's sitting at 60 miles. So you could picture right here as being a trip from, I don't know, your home to somewhere 60 miles away. Then you went shopping for, I don't know, 7 hours. Well, your car didn't move. It sat 60 miles away from your house. So 60 to 60, that's 0 miles. Then what happened is on your way home, you decided, so again, this point 0 is your way home, so you start traveling home and you stop somewhere that's 20 miles from your house. So you were 60 miles away, now you're only 20 miles away. Well, what happens a lot of times is students will look at this and be like, oh, well, that's negative. But we're asking how many total miles did the car travel. So the miles from C to D are not subtracted because those are still part of the car's trip. So in this case, you were 60 miles from home, you travel, and maybe you stop and get some food. That's 20 miles from home. Well, that's still distance traveled, so so far you've got 100 miles, and then you decide to just get out of town. You're just going to up and leave. So you were 20 miles from home. Now, in a very short amount of time, you travel, and you are 210 miles away from home. So now you're 190 miles further from home still. Well, so to figure out our total miles traveled by the car, you're going to take your 60 miles from A to B, plus your 0 miles from B to C, plus your 40 miles from C to D, plus your 190 miles from point D to E, and there you get your answer of 290 miles.